kidding me, right? Wow. Can everybody see me now? This is I was talking into the void because in live streaming I saw myself here, but I had to push start stream here, even though OBS was streaming already with the key. Why? Okay, so now I get people responding to what I'm saying, and I hope everyone can see me clearly, because yeah, just because it's the first time with this computer apparently that I do a live stream with YouTube directly and not with anything else. Hello everyone, welcome to the show. YouTube was telling me that the stream it's getting is only 360p. Is that correct for everyone, or do you see me in HD, or what's the resolution I can work with? I could try to watch it actually. That would have been so much better as an idea. 720p is the maximum I get. I think that's okay. Okay, clean your glasses. It looks alright. I recently upgraded my internet connection, so this shouldn't be a problem. I'm a bit surprised that it's only 720p though. Yeah, it's not that super crisp, but that's something I should work on when I'm not telling everybody that I'm streaming, right? So I also have a second monitor that I have no idea where on this monitor it goes to. Oh, there it is. Okay. Well, yeah. So I hope I'm not streaming any forbidden informations. Yeah. Wouldn't be the first time. Alrighty. So what are we doing today? We're trying to program something for a small Arduino board, and I don't have the camera feed of that here, and I should play with that as well. I'm so sorry. It's Friday. We can all just be happy that I'm not drunk. Yes. So camera. Yeah, let me just hold it into the camera first. So I'm not sure if everyone has seen the Space Invaders Arduino handheld thingy that I made. It's LED based and has those, well, let me wait seconds for the preview to finish. But we have small asteroid Space Invader aliens on here. The LEDs shine through the PCB, and that's all cool. And I never finished the code, but I got to a point where I was a bit happy about it. Very tactile buttons. Yeah, I really enjoy handhelds with LEDs, and the concept was great, and we're not programming on this one now. I recently found something on Tindie, and the link is in the description, where someone made a TicTacToe LED board game, and it's not turned on, and I don't have the 9-volt block, because I don't have 9-volt blocks. But we're working on 5 volts for programming it anyway, so we need to attach a cable for power now. Alrighty. Very long latency. Okay, yeah. This was sadly to be expected for some weird reason. I really have to fuddle with the settings Okay, there we go. Here's the yeah, there's a little animation that I've put on already. When you start it, you can see a circle and a cross. Right, and then between the LEDs, should really set this up here. This is so wrong. I have the webcam dangling on the lamp now. So let me quickly add that. This was over here. It wasn't. Was it? VLC. Oh. Video capture source. Why aren't they just calling it webcam? Right, there we go. And I don't like the frequency of that. The power line is 50 Hertz. It hurts. Wow. Oh. Alrighty. I have no idea where to put this. Let's put it here. Right. It's not really great for correcting. I was waiting for the thing too long. Let me start Arduino while I wait for the position to update. Let's make a new sketch. New window. And I'm typing on the wrong keyboard. Tindie. The Tic-Tac-Toe kit. So it was a very cheap kit. It was 15 euros, $15, sorry, and also I think 18. Yeah, there we go. $22 shipping to Germany. So all in all, I paid 30 euros for this, and I think that's a very fair price for a kit like this. And it was fun. I was soldering this for when the last MakerCast was airing. So yeah, I had the fun of live tweeting the MakerCast while soldering this, and well, I think it took me about 3 hours to solder this altogether. And yeah, I just worked longer on that one. Yeah, so let's go to the documentation. Blah, 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 blah. We have the schematics. You can take a look at that in a second, and then also the Arduino code. And this is not coming in a folder, so I'm just pasting it here. And we're saving it as desktop. Tic Tac. This is not the name. Desktop. Up here. Tic Tac Toe. Okay. Yeah, shipping is kind of expensive, but if you just add up all the things, then it's kind of worth it, I think. I don't know. I don't have a good sense of money and what things are worth what. Alright, so let's quickly look at the schematics. There are one or two things that I was a bit skeptic about. There are two 100 NF capacitors in here, but they go up to 100 volts. So I'm not sure why that was done. These are the brown capacitors over here. Yeah, other than that overview, you have everything's DIP. It goes through the PCB, so yeah, you have to live with the consequences of that. But you have to solder something by putting it in one side and then flip the board and hope that nothing falls out, or not everything, and then you're soldering it. I made sure that all the resistors are in the right orientation. Yeah, you get 120 ohms in there, and then you have, I think, 10K resistors for pulling up some data. Right, and to work on this today, I made some modifications. I firstly added an SPI connector here, or an in-system programmer adapter, and then soldered it to the pins of the Atmega that was needed. Because the kit came and the first animation that showed was going for 32 seconds before you can play, and that was probably due to the fuses not being set, and it's supposed to run on a 16 megahertz crystal, but I guess it was running on the 1 megahertz internal crystal, so yeah, there was a bit of a delay. Right, so I added that header, and then I thought it might make more sense to have the FTDI header on there. So in case you like, yeah, what does it mean? Yo dog, I heard you like programming headers, so I added a programming header to the programming header, and just soldered on the 6-pin header of that breaks out the FTDI. I just glued it on top of the ISP SPI header, and then soldered this also to the concurrent. There's a word that I'm looking for, but yeah, I was just soldering it on. As well, without hot glue, I might say. Just good old heat shrink tubes, and making sure that the cables are long enough, and then hopefully it should at least work out for today. Right. So yeah, that's a pretty nice kit, and links are in the description if you want to buy one. There are a lot of options when you're buying it. Yo dog. Right. I just told them that's totally fine that I didn't select any LEDs. I have my own, but you can also get red, green, and blue or yellow LEDs with the kit. But I thought, yeah, that's fine. I have so many LEDs. Yeah. So that's a rough overview of the kit. Let me power that again. So, yep, that is correct. We have the startup animation, and then it starts with player X, and then it's just, oh, danger. What can we do now? We're not gonna do the chat against me game here. I totally missed that I already won with the crosses. Never mind. As you can see, there's no detection if someone wins, if any of the color wins, and it doesn't reset or do anything. That's what the reset button is for. And then you basically start the program again. That's quite an expensive project you've worked on there, the embedded hobbyist. But it's you, so yeah, I think you often do that. More expensive stuff, not that expensive. I have no idea. I might confuse you with someone else. Let's carry on. Right, the plan. Let me grab some notes. Totally fine. I might look like the other meme with a crazy guy from It's Always Sunny in Philadelphia. Because I was sitting there yesterday thinking about how I can actually detect that someone wins. Because I thought that would be nice. And also I want some, maybe a good or a better startup animation like the one that I've already done. And yeah, I was thinking about the whole tic-tac-toe theory thing. It's not really crisp there, isn't it? I'm turning it that way, it just turns like this. I'm not sure if you can read that. There's also a shadow of the camera below the... Right, you're exchanging very expensive projects. I'm really happy that I had never such a big project to work on. I think the scariest thing that I did once was I was responsible for credit card payments being withdrawn from just one customer because we stored that for that special user that everybody was using for everything. So at one point we had to give all the money back to that one person, and I think that's the most expensive mistake that I ever want to make, and I didn't even pay for that, so I'm not sure why I'm saying this. Is this not IC controlled? It is IC controlled. We're talking about programming something. Oh. Sorry, Adam. Yeah. I'm not sure what the delay is, so... And I also didn't see that there was an M missing. Right. Ooh, yeah. So this is not that expensive as well. Let's go back to the tic-tac-toe thing. It is IC controlled, and the reason that I added the FTDI header and the ISP header is there's an Atmega328 or 328 328 on there. So this is a let's program something in the Arduino IDE video. I hope you all read that before and aren't disappointed that much. You've been warned before, but now you're warned again. Right. I should have scanned this and showed this here, the whole theory thing that I made. I don't think I have a program installed for... Oh, didn't want to show the files. What I see. Was it a PIC or a newer Atmega? Right, yes. That's a huge delay. Yeah. You're probably just wondering, what? You're seeing this now? Disciple, you are not late. I am late, so you're on point. We're just taking a look at the whole thing here. I even have the schematics open. How do I close that on here? There. Right. So this might be better for everyone to see. I can also move that over here and this over here. So yeah, you don't see the LED section, but that's basically like this. As well, it's connected to C1, C2, C3, so that's for column, and then you have pins for the rows, and there's some matrix switching in there. I'm also not so sure about the power consumption here when you put them in parallel with the same voltage. It has a 120 ohms resistor on there, but that should be plenty. I haven't really tested that, but it should all be reducing it. Well, it's probably self-regulating in some weird way. Yeah, okay, you can see the chip now. That makes sense because it was smaller before. But this blob is the chip. It seems like basically all the pins are being used because you have the LEDs. That should be a 3x3. Nope. It's more. You have twice the LEDs because it's always XO, so it's 3x3x2 LEDs, or blobs of LEDs, because you have the 4 LEDs that form an X and the 4 LEDs that form a 0 around the button matrix that is over here. And there are the other 10K resistors, so there's no de-ghosting with diodes on the matrix, which is totally fine because you only ever push one button. Right, and the code is running all the time. There's no debouncing for the buttons, which you kind of don't need, because as soon as you push the button, the state gets written for the LED. So if you're the circle and you are, yeah, Bleep Track just joined. Hey, I haven't said hi to everyone. I'm sorry, that's not yes, but it pulled me out of the track of me talking. They didn't multiplex the LEDs with the buttons. Yeah, they could have probably done that. I think that is in some ways a beginner's project, because there are some hints for that, because there are capacitors in there that are rated for 100 volts, and they look pretty beefy, and they are on positions that you probably don't need them, or not all of them, because you already have them in here. So you never would put 2 more caps in there unless you've seen that in another schematic, I guess. And that's totally fine. I've stolen so many things from other people's schematics, and it works, so who would care for that? There's a diode on the switch. That's a thing, I guess. Anyway, right, I was talking about the code and the debouncing right now. You don't have anything for ghosting or debouncing the buttons, which is also not really necessary, because the state machine works that way. Once you have pushed the circle, the state is set, and you can't override that, so it wouldn't rotate or randomly switch your button push. And yeah, so that's kind of cool, but I'm not sure if we have to reprogram that. Oh, PIC projects. I've never programmed the PIC before. You never need any capacitors. Yeah, right. So the Shippo is the master of leaving parts off the board, and it still works. you made 1 or 2 boards where I was like, okay, you only have 3 parts on there. One is the USB socket, the other one is the SAMD, and then there are like 2 other things that you kind of needed. Capacitors are a scam. I wouldn't go that far. I think they have their value in yeah, where you use bigger chips or more MOSFET stuff. Right. Okay, so does anyone have any questions about that design? I think it's fairly clear, but I have to wait for questions. We have a regulator on there for the 9 volts input to go down, which makes sense. Right, there's no header for reprogramming it, but I guess you're supposed to just remove it, or it was never the intent of people reprogramming it, so that's why I added just the sockets for everything. See, so they aren't a scam. But yeah, right, I have that and the LEDs for this. Okay, there are also weird cross connections. I guess that's for, that's not that weird. If you just look at it, you see that this is the Arduino naming, so that's easier for programming it. And then you have this matching board, but it makes it a bit harder if you want to track down which pin goes to what. But you don't really have to know that anyways, unless you really want to reprogram everything. But the code is under some kind of license that should allow me to work on it. I'm not selling it, I'm not making any money off the stream, so I don't think it's that bad. But yeah, I'm trying to see if I can give the code back in some form and tell that person. Right. I think that's one too many. It's getting dark. What is getting dark? Hey Dustin. Okay. Tic Tac Toe. We just copied that. So let's quickly look over the code. There's a renaming of the pins, so we know what row we are talking about and which pin it is connected to. Turn, I think that's the value where he's flicking through 1 and 2 for 1 being X and 2 being the circle or O. Right, and then there's the single array for the state, and for the startup it's 1 2 1 2. Oh, right. I haven't changed the board here yet. AVR boards, let's take the Pro or Pro Mini. And before we are working with the USB stuff, I have to program it with the AVR header, the ISP, SPI. Okay. So 5 volts, 60 megahertz is correct. And we want to burn the bootloader. This is just to make sure that the fuses are set correctly, which was not the case when I got the thing. And also I want to burn the bootloader of Arduino on there so I can work with the USB serial connection and have some debugging capabilities. This might take a while. Bing, 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 bing. Done burning bootloader. Okay. Let's find out if that worked. Or where did I throw the? Ah, yeah. Okay. True meaning in Python. Yeah. I'm I'm quite happy that it's not a Python capable machine, because otherwise I would have to learn Python at the same time as working with it. I'm sure there are fairly capable people that could have helped out, but this is not the tool for the job this time. So we have the TTY USB here that shows up, so I'm happy about that because I wasn't sure if that FTDI programmer works. Compiling works, so let's put it on there. Hi Rory. That didn't work. I mean, if it doesn't work, then we can try to debug it, but what's the ground? Okay. What? Oh, okay. So I pushed some pins back. Yeah, that's the bad part about it. I soldered something like this, and we're uploading, and it's doing its thing. It's flashing. Whoop-wee! So that was the original animation that you just saw there. I thought it would make sense to show the circle and the cross with this with the right colors. So that's what I had working yesterday. But Python is designed for people who don't know Python. Okay. I'm not sure if this is a good thing. I mean, it's a good... Right, you're trying to remove the maybe unnecessary steps of the Python background and just focus on getting the logic done instead of the parts below it. Like, maybe? Yeah. Yeah, this is totally not a beef thing about Python. I'm just really happy that I don't have to right now. It's Friday. Hi, meh. Has there... Yes. You're probably asking that because of the delay. Yeah, it was just the pins weren't... when I plugged in the connector, I pushed out the pins from the pin header, and just putting it back fixed everything, and it's working now. So it's done with the uploading as well, and we saw the animation, and this is working the way it was supposed to be working. So That is not the end of the stream. So I basically spent the last half hour talking about the thing that I bought and what I did to it hardware wise, and now we're looking at the code that was handed to us by the developer. Right. Okay, so the setup is normal.
In Berlin beträgt die Temperatur aktuell 7 Grad Celsius bei überwiegend bewölktem Himmel. Der Wetterbericht für heute Nacht sagt Regenschauer voraus, mit einer Tiefstemperatur von 3 Grad.
So if anyone was wondering how warm it is in Berlin right now, it's 7 degrees Celsius and 3 degrees are expected to be here overnight. Right. Okay, setting the pins. This makes sense. This is for all the rows. If you turn one row on or one column, and it's probably something like high and low, and then the LEDs blink, or not blink, they glow. Right. So it's waiting for a second. No, it's not. They were working with millers in a very weird way for my brain, and it's also not unsigned long. The bald engineer James was telling me that once. So before we forget, let's put it there, and now we have something to work with. 7 French degrees. Yes. No, the C stands for Canadian, of course. And they have imperial measurements. Metric. Wow. I kind of feel drunk without drinking. This is weird. Anyway. So we were talking about setting up the pins. And the startup time thingy in the setup. So there's not much to it other than that. There are no sensors that we set up, and there's nothing that we wait on. There's no serial in here. And then there is a loop, and this is all the loop. The loop is very long. Here we are at the end of the loop, and then we go back to the beginning. So the main things that are happening in the loop is it first checks for the animation that's going in the beginning. So if you have to reset it anyway and it just happens for one time, you might want to consider to put it in the setup. But there's a small exception. Here he is going through all the positions and flipping the state from 1 to 2, so turning it from 0 to X. And you also have to have the displaying something going, because it's in a matrix. You constantly have to switch on one column, set the bits that you want to have the LEDs shine in that column, then quickly go to the next column, turn the other one off, turn that one on, and then do the same. So you basically are running through all that all the time. So what he made here is just after a certain time the timer runs out, he flips the bits, and otherwise he's just running through the lower part here of showing the states of the LEDs, which also looks a bit bloated. I don't know, it doesn't feel very code effective, but it's correct. So I don't think I will work on this today because we have something going here. The same goes for the buttons, but we're not doing anything. Well, here's in here there's the code logic, let's scroll up for one button. So once the game has started and the animation is done, it flips into the startup level 2, which means it's done with the animation, because here it checks for startup level 0, which is the starting point. Then the next frame, I guess. And after that it switches to startup level 2, so you never come into the startup lights animation thing. Which kind of makes sense. Yeah. And then the buttons here get controlled. So you could probably, let's just try this, but because this is running, you should be able to play the game while it displays something completely different. No. Well, it has the start byte. When you then start the console, you can play it, flip some bits. No, you can't. I've never thought about the whole process, but since the whole logic is within the buttons, it always checks for the state of the thing. So if you have it show one color or one symbol, it won't work anymore as a button. So you can't play while the animation is running. That's kind of funky. 32 bits. I'm just checking up on the int32t and the like. Right, but I'm not sure if this is related to the unsigned long, but the millis returns an unsigned long, and if you don't work with that, then you get, when you calculate with it, you get weird results sometimes. Well, at least unsigned long versus long makes sense, because with one you go to 2 billions. Is it 2 billions here? 32 bytes? Something like that. Just broadly speaking, with one you go to 2 billions, and with the other one you go to 1 billion in plus and 1 billion in negative -1. Yeah, it's numbers. So calculating with one plus the other doesn't make really that much sense. So yeah, otherwise I'm using the uint32t and 8 and 16 as well. Right, so that was just me rambling about something. Right, you all saw that it's not really intelligent in that sense that there's no detection for win. You probably wanted to stop or show like who won, and this is something I want to do today. And for this I had some thoughts. I was drawing up some theories about it, and I was coming up, well, I was just looking at how you can win the game, or what's necessary for you to win. Let's just make some notes in here. I shouldn't look. I have a German keyboard here, but I'm used to the international US keyboard. I can't tell you why. Changing the turn really has a lot of duplicate code. Right. Yeah, you have pressing the buttons, and you're just allowing the button press if the state of that particular field is 0, which makes sense. If it's 1 or 2, you don't want anyone to push again there, because Well, it doesn't make sense. It's already taken. So you can only click on the 0. Right, and then... Oh, that's interesting. Okay, that's probably what we're talking about, man. Oh no, you have the turn and then you put it in the state, right? And then when you are 1, you turn it to 2, right? You could probably toggle this a bit different. It might work better if you're working with a Boolean, but then you would have to basically have 2 arrays, one Boolean array for one player and then another one for that player, or even 3 if you want to have the field there. So that's a bit tricky. I think that's okay to work with and to understand and maybe change. Normally if I have something like this that is that much repetitive, I would probably go through an array of things and just say for each, sorry, not for each, but with a for loop, I have 9 states. Let's just go through 9 states, check if the corresponding button is pressed, check if the state of that is correct, and then just do the turny turn thing. Yeah, it would be easier if it was 0 and 1, because then you could make 2 the state that's the taken one, and then when you work with 0 and 1, we can just say turn is not turn, and then you have flipped the thing without the if. Yeah, there's really, you can maybe just count the seconds when you send a message, and then see how long it takes for the message to pop in here. Yeah, I haven't done anything to the whole streaming settings, and I'm sure there's probably a lot that I can change, but I should be able to stream faster and with less dramatic delays. You could use a function on change players for every button press, but as far as the code works, it's fine for such a project. No offense. No, I also no offense taken, because I didn't write that. So we're going through the code that was delivered on the Atmega328 that I bought. Yeah, I totally want to contact the person because of the fuses that weren't set. I think that can happen. Might be an accident, but maybe they need to know. So yeah, that's. But I also probably sent the link to this stream as well. Bloop, 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 bloop. Posted at 2031. I hope you're not using. Oh, you're using times. At least use seconds to make me feel better. Or is that just a mark for you and you're counting? Right. Okay. So Boolean, whatever. But so I was thinking about the whole trying to find out if you have 1 or if anyone has 1, and then I was looking at the numbers that do correspond. Yeah, just scream if this is readable at all. I can probably use another editor as well. Let's just go big. I'm already home. 1 minute. Okay, that's insane. Yeah, I'm not in Australia, so you should get it more quickly than that. I'm sorry, but yeah, it should be fine. We're not that interactive coding here. I'm just not getting all the how witty and on point you are with your comments about things. Anyway, 1, 2, 3, 4, 5, 6, 7, 8, 9. So just a little refresher. If you haven't played this in a long while, that's totally fine. You basically start. I think the X person always starts, and then you try to fill up all the fields. How can I? There. This one. Bloop, bloop, bloop. Nope. This is also, I'm really not used to all this keyboard stuff. Right. The count. Anyway, this is the field that you have, which you can also see on the LED thingy. And most of the time the person that plays starts with an X and also starts in the center, which kind of makes sense, and I'm getting to that in a second. But then the other person plays 0. We don't want it, the row to get there as well, but this time we don't want the X to win. So the X thinks, nope, you can't do that, and 0 thinks, haha. And now X is like, oh, where can I put it? Well, it doesn't really matter at this point, I guess. Can I win against myself? Oh. Right. Yay. Okay, so yeah, the lag can be totally on me, but I'm not thinking that my computer has any problems with the stream itself. At least I hope not. Wouldn't make any sense. Yeah, I have to just take a look into that, how to get better timings, because my internet really isn't that bad. Alright, TicTacToe. Here we go. Nobody won. So I was looking at this, and then I was thinking, okay, what do you need to win? You need you can, some even call it 3 in a row. So you can have a row, you can also have a column here to win, or something diagonally. So I took a look at it, and then I just took notes. How did I do that? I had something cool. I also drew a state machine. Thanks, Adam. I feel totally fine live streaming this now that you. Hey, Sebast. Right. Anyways, the rows. I was thinking about the combinations, and then I drew something like, oh, 1, 2, 3 is one combination, and if I keep on going with the 1, I see that the 1, 5, 9 is also a combination, and the 1, 4, 7 is a combination. And then we have the 2, 3, 4, and nothing more on the 2. We have the 7, 8, 9. We have the 2, 5, 8. Oh, it can go up there. I could also just cheat. I have it written down somewhere on my crazy notes. Right. 8. I need 2 more. So 2, 5, 8 is this one, and this one. And there's no other 2 in there. Cheat. 147, not 146. Yeah, right. Sorry. That's a typo. So 147, 789. I have it up here. Right. So we need the 4, 5, 6 as well in there, and then we have 1, 2, 3, 4, 5, 6, 7. 1 is still missing. 3, 6, 9 is missing. Right. 1, 2, 3, 4, 5, 6, 7, 8. So that's the combinations that you can have, and with that you can already just, when you push a button, you can also just check all the combinations. 3, 6, 9. Yeah, must be. I'm sorry for for the delay. Must be frustrating if you type something in and I'm like, why don't you see this? And then I'm like, oh yeah, 3, 6, 9, and then minutes later it pops up there. Anyways, hey Tabletronics, I have the combinations of possible wins in here, and we could now 2, 3, 4. Wow. Yes. I totally not meant 2, 3, 4. Which one was I'm going for? So there's only 2, 5, 8. This doesn't make sense. And 1, 2, 3, 1, 5, 9, 1, 4, 7. Then there's a 2, 5, 8, a 3, 5, 7 is in there. Wow. 3, 5, 7, 3, 6, 9, 4, 5, 6, and 7, 8, 9. I think that's okay now. What can I say? I'm 3, 5, 7. Yep. Yeah, probably. Edit that later. Right. So these are the numbers, and it's the constellation combination, and I gave them names. Right. So it was late yesterday, so when I first looked at this, I was like, there are a lot of 5s in there. 4, to be exact. And then I thought maybe I can make some sort of binary tree and some clever ifs, and so if it's someone's turn, I don't have to go through all the combinations and check for them. I could maybe just be cool and say like, oh, I have a 5 in there, so let's check those combinations and leave the other 4s alone. But yeah, I got to this binary tree here, which was like, okay, I'm starting with a 5. If I find a 1, I have to also find a 9, and then I win. But yeah, what if I don't find a 1? Then I have to look for a 2, and then maybe an 8, and then I win. So the further I got with this, I was like, wait, that's not really a more logical way to go through all the solutions with an if. at a distance with a 762. I'm fact checking you here. 762. I mean, this is basically, that's almost a glider. This would be missing, but yeah. Oh, hi James. That would be Sonic Alchemy, and we have this thing when we say hi in the hex space where he says hi Dave, and I say hi James. And Alex is here. Stream's still going. Yeah, well, it took a while for the stream to start, but I am here, and we're going through combinations of TicTacToe wins. Right. Yeah. The binary idea with the 5 starting there and then going to look for the other combinations, which is also kind of nice, is like 2 plus 8 is 10, so I was thinking about maybe adding up all the numbers, and then I can see that if you have this and that number, then you have one something. But yeah, that would have made sense for the 5, but yeah, that's right, no trees involved. But then you only, yeah, I just saw this, but Dave is lagging. Dave is lagging a lot, yeah. The +1 and the -1, right? Then, but then you only have a. Then you only count whose turn it is, because it evens out whenever 0 is done, so you get the X. Right? So yeah, you could have and field not played 0. Yeah, right. So when you add that up, you only get whoever turn it is, because you have -1 or +2, +1. If you start with 0, oh, it's always 0 or. Yeah, I don't think that's making sense to me right now. Doesn't mean that it does not make sense. It's just I'm not following it. Right, so binary tree would be out of the question. But from that, I was thinking, okay, I only have to check. If I click on something, I know the number, so I can basically see. If I have a 2 in here, I only need to check for 1 and 3 or for 5 and 8. So this kind of made the thing easier. And yeah, I could do that. Then I just have to check for that button and have a weird but long if. Right. Yeah, I'm just looking at my notes. Because I got this weird idea on how to make an enemy for that game. And the idea here was to have states for the kind of win you get. I have this little table here that represents like 1, 2, 3 is A, and this is the first row. And you basically say when you have number 1, you have the A combination as a possible option. And you also get B and C, which would be the diagonal or the left column. Yeah, So the same goes for all the other values. And what is the whirling sound in your room? Oh. Okay, everybody, don't freak out. I might move the microphone. It's still sitting on the computer. I move it. Can I? One, 3, 5, 7, 9. That is 1, 3, 5, 7, 9. Oh, that's a double win. We would never come to the double win, Adam, because we wanted to stop and tell you that you've won. Oh, unless you don't start with the 5, put them all in place, and then you're actually... Oh. Well, I'm getting so distracted from everything. Right, so let's just bloop, 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 bloop. I don't think anyone would ever do that, but you probably mean that, right? Two audio sources, yeah, because you're closer probably. Let me remove that. This is the mic, and I have no idea what this was, but headphones. Okay, yeah, sorry for that. You were completely right. I had the microphone still sitting on the computer, and there's a fan in there. Right. A double win is possible. It really is. You're probably now seeing the double win being shown by me. Okay. Yeah, I'm just trying to follow the chat. As in, see when the update is coming. Oh. Right. Yeah, you have been. Oh, okay. This is... How do you not put the circle in the middle when you have already like 1, 2, 3? How do you... Well, I'm not judging. I'm really not judging. Okay, so yeah, back to the thing. We have some probabilities here of winning if you start with a 5, because you have 4 combinations for the 5 to win. And some numbers aren't that lucky, because if you play the 2, then you only have the first combination and the 4th combination to win. So yeah, you probably don't want to end up hitting the 2 first, but you can maybe turn that into a win as well. Yeah. Right. So looking at the probabilities, I was playing this for 1 or 2 moves. Let's just put them in here. A, B, and C. It's always good to document anyway. So this is C, D, E, F, G, and H. Winning combinations. Now a triple win. Well, we probably have to add some LEDs then. So these are the winning combinations, and when we kind of invert that matrix for the probabilities. Oh, I hope this is right. I'm just typing this off from the cheat that I made. 1, 2, 3, blah, blah, blah. This is in order, isn't it? 258, 357, 369, 4. Yeah, right. So I ordered this by numbers. Not that much. It's actually more a up. Anyway, you see the logic, and that's the same, so I'm happy about that. 3 is AEF. Oops. 4. Let's see. Let's just type it off here. Right. So people who start in the corners have a better probability because they start with 3 winning solutions. And yeah, the most challenging way to win a thing is when you start up here, I guess. So, yeah. There are a lot of combinations for this to work. Okay, 4. It's C and G. This is one of the C was going down, this one, and then only going that way. And that's 4, 5, 6. So G. Right, and number 5 is the one with the most combinations. And number 5 is B, D, E, and G. Six. F, G, C, E, D, H, and B, F, H. Okay, let's just... How is a triple possible? I have no idea. Oh. Right, so these are the combinations relating to the numbers. So if you... one is missing. Seven is AH, CEH. Right. So when I had this matrix, I was like, okay, wait a second. This means if I do this right, like track all the combinations that are possible for each player, then I can also make an enemy that is just looking at these numbers. Oh, sarcastically, a triple is possible. Okay, I'm sorry. Yes. Wow. Wow. So this is not only the long line that the internet connection was standing on, but I was also standing on that long line myself. Okay, yeah. Oh, Johnny. Okay. This is a very bad stream for programming, I guess. Right, so we have the combinations. If you just looking at this, you would probably now all start with the 5 or the center position with your X. And if you imagine you have this matrix for the X player and the 0 or the circle, then you can. Oh, it was very late at that point in time, but I was playing it and then I was crossing off things, and when I started I had the BDEG combinations, meaning I was able at this point to get all these moves. So when the circle's turn, when it was the circle's turn, it wasn't able to select the 5, of course, but then just looking at it probably takes the first of the 3 choices, and it probably has put it in one of the diagonal thingies. So let's just say we put it in 3. This would mean that of the 4 options that I had with the 5, now that I use the 3, A, E, F, the E option would be out of my possibilities because someone took it out of there. So E is 3, 5, 7, and these are basically matching only here. So when I start with a BDEG, I basically take, right, it's the computer X or O. I think it makes sense when you are always X. We can talk about modes, I guess. But with just the logic that I was thinking of, the circle would, well, the computer would always choose the 5 at the beginning first, so I think it makes more sense if you always start and then you can just select something else and then you can let the, well, it would go for the 5 if you don't choose it, so you have to live with that. Right. So there's no clever way of, oh, I'm starting it from the other side of the line that I'm trying to draw or something like that. So I don't think it would try to make a circle first and then hit the X and do a double finish. Right. And it would never go for 2 and 4 and 6 and 8 first. So that doesn't make sense. Right. If the computer goes second, it is possible to never beat the computer. That, yeah. So unless you make a mistake, you would always end up with a draw. So that doesn't make sense either. Right. I think the first idea is to just track if you've made one of the combinations first. Right. And then I was just drifting away, looking at the possible combinations and how I could track this and how I could, basically work out that if I have the BDEG, when I take the 5 first, these are the options that I can work with. When now the other player looks at it, it's not able to go for B, D, E, or G. So if I would work with that matrix for the other player, I would have to remove those possibilities. So B, D, E, G. So now the computer could, or the the microcontroller could now just it would just look at this and would probably go for AC. Okay, Adam is very certain that you can beat the computer then. You probably can because you start with X, but yeah, nope, forget that logic failed me. Okay. Yeah, it's late. Never mind. So just looking at this, this would be the possible lines that the other computer could go for, and would probably go for 1 because that's the first one that it sees. So it can try to go for the upper row, for the lower row, for the side, or for the other side. So if you don't want it to be smart, then you could say just randomly pick another one and have it not try to reach a goal. But if you work with that like this, you can probably have it beat you, because now it would go for 1, and then you can either try to disrupt that. But yeah, if you, let's say it would go for 1, then you would remove all the A's and C's in here for the other player. So it's just right, let's say it chooses the 1. Oh, sorry, copied the wrong one. So since we took the 5, we have all the options still left, but when this one takes the 1, we lose A and C. That's it. Right? So these would be the options for the O player, and this is the X player after that. And right, the 5 was played, the 1 was played. I also have to take, yeah, you also have to have a track of that, but you also have the states saved somewhere, so you know the game and which things to play. And since this is my turn now, I can I can still go for B, D, E, F, G, or H. So I could choose the 9. That's interesting. And then I have B, F, H. Is everyone following me? Or so. I will open source it, definitely. I didn't start the GitHub thing, but yeah, that's the plan, so I can easily share it to the person that started the code. But yeah, okay. Pretty sure I took the X here, and then it was Zero's turn. And now, since I'm looking at this, BG, I can now go for 9. That's something that I've never thought about before. Why does it make sense? Does it make sense? That's something that I would have never done playing it, because this just means putting an X somewhere that doesn't influence the 0. So interesting. Okay. I think I learned something. Right, okay, so I chose the 9. And I destroyed BFH. I can still go for BFH, that's why I didn't remove it here, but since I used BFH, I can now remove F and H in here. So we can go for, oh, we already had that. So we only have A and C for, right, we can only go that way or that way. We can't go around here and put it here. So that's something interesting. I just learned a new move. So we can think about putting it on 2. Sorry, that's 2, 3, 4, 6 is still in the game but doesn't win me anything. 7 and 8. So if this one was out to win something, it would probably put it on 2. Yeah, this is so weird. So 2, and since A is already removed from our scenario, aha. Okay, so when I chose 2 up here, and this also means that I have to remove the D option now, because this was placed. I think I forgot that before. So I'm not really sure if I'm going to tackle the whole I'm smarter than you routine. We already have the 9, and we still have that going for us. Right. Yeah, so I can probably beat it. Wow. What? I'm completely lost. So this is why serial debugging would be important then. I chose the 2, so A is still in the game for us. We removed A and D as an option, but this also means if D is the one going down on the right. Is it? 258, no, that's D. Okay, that makes sense. This is the one we can't play. I'm so lost, I'm sorry. Right, we didn't have D. This is downwards. On that side, that's F. 369. Can still go for F. Well, this is the part where I would now just put it here, so this one can't edit here, and you kind of have to put it there. But at this point I'm not tracking that I have a chance to finish here, so it would probably, let's just say 3 is out of the question, then A is crossed off. This is already recorded for me? What do you mean? I'm not interested in seeing anyone else doing it or just copying it. It's more interesting to think about it, but I don't think it's interesting to stream me thinking about it. So that's a bit of a topic there. But yeah. Right. I think it's safe to say that we should go for and check for the wins now. We're not trying to solve this solver, I guess, right? But it's interesting to think about all this. We have the 2 here. There should be. This is a bad example that I went this way. I should have gone this way with the 0. Because then it would probably have gone somewhere else when I put the X here to... I don't think it would know that it can win by just adding something here. It would just start from the top, and if you have just one chance here and one chance here and one here for a combination, then it would just go with the first one again. And it wouldn't, right now it would go to the 3, but if there's a 0 here, it would still add the 3 first and not put it here. So that's a bit stupid. You always have to track somehow that you're close to getting a combination done. So that's something you would have to figure out if you want to have a smarter enemy, I guess. But yeah, that's the gist. Okay, so I think for the first step it makes sense just to, whenever there was a turn or a button pressed, we check if, let's say we have the 5, we check for the combination that are possible for the 5. If that's the same person. So it's, since we have for every button we have the routine already, we can add the logic for each state, right? Let's maybe do that first, and then hopefully some people are inspired to also think about how to solve a tic-tac-toe game on an Arduino. Okay. Right, so let's find the entry point. This would be here for the state 1. This is when somebody pushes the 1 up there. So let's just take the copy. Yeah, that's the combinations. Let's just take them with us. And I should probably make a function that's getting called somewhere else. On a Merlin toy. Is that like also a handheld with LEDs? Is that maybe a clone? I never checked that. Oh, hi Sion. Sion. Non-easy smart mode should use the L inverted L trick, i.e. 197, or is that called the double? the 1, 9, then 7, or oh yeah, that's the cross where you go around. That's how I got to this part here. If you start, oh yeah, animation, you start 1 point, bloop, bloop. Did it just reset? Did I break it? Okay, might have shorted it somewhere. Right, you can go around, and then in the final step finish with a double thingy. So I guess you would still recognize, because you're matching one of the diagonals that you want, you could go with a bonus round if you see that this combination was done. Like when you have one diagonal, check if you have the other diagonal, and then you can also say like double winner. So yeah. USB-C on. That's so funny. Alright, so the buttons. Just check the buttons. This is a bit... Okay, I'm thinking in functions here, so we're calling a function at least. Don't be alarmed, I'm just writing it in here, because then we have everything close. I'm gonna copy it out, but that's probably something you don't like to see. Right, so we're not returning anything, and we have a function that says check for win. Whoopsie. This is so annoying. Can anyone... Okay, you pro... Oh, I'm in a screenshot. Nice. So when I do this and this, why is it? It's probably expecting that you're starting to type here, but it's always annoying that it jumps there with the clamp is coming with the swirly thing. Anyways, so we do expect the turn is an int. Let's quickly change that, because that doesn't make sense at all. We only need 1 byte for this. Okay. Where did I... Here. Okay, check for when. We have the turn that we're working on. I don't really have... Okay, that's not necessary, because it's a global variable, so I don't really have to check for that. And we only have to know what button is pressed. So we are expecting a number. We can probably also start the... We can add the serial console in a second, but serial print line button pressed. Okay, and we want to tell the serial to run at some form of speed. Serial begin. Is that even a number? What's preset? 1152. Okay. The numbers were there, just in the wrong order. Right. Right. Line. Print line. And we say Tic Tac Oh no. Right. So it's just, of course I did that. Button press, it's probably because I called it check for win. And button press is the function name. So this is why I at first put it in there. Yeah, thanks, Jan. There's a bit of a delay. You might know how that feels. I'm sorry, that was mean. But yeah, there's like a 1 minute delay. I haven't checked anything. I haven't done anything with the settings. I just panically hit start. Tic Tac, oh no. On the stream because I was late for 10 minutes and then it wouldn't show until I noticed that I have to hit start stream in the web surface of TicTacToe of YouTube. So button pressed, I only have it for the first one, but yeah, and it doesn't trigger anymore because the state is not 0. Right. So I can I can add that to every button press now. Right. Why is this state 3? I should probably. Oh, okay, yeah. So because we're going through the columns, this is here. You can see that the column is pulled high, so we are now checking the state 1 or 0 because we start at 0, 4, and then 7 probably. So this is also, even though the 1 is feeling more natural, we say this is 1, this is 3, this is 6. Okay, and I'm just making sure that this is just everywhere, and then I can turn this into a, what was I going to say, into a for loop. Right, so now the column 1 is turned off and column 2 is turned on. And we're doing the same for 1. Sorry. This is annoying. Okay, let's just imagine that I did all that, and we're turning this piece here into a function now because this is annoying. I just have to make an array first with the no, this is R1, R1B, R1B. Okay, so that's not really sufficient compressed, but I don't. That's an Atmega328, so let's make this a function. Set it's a button pressed, we're checking a state, we're setting a state, we are doing a routine, so it's the player turn. And we also get a uint 8t for the segment. Let's just keep it simple, use I because we know it. Okay, we have to do this all the time. I'm just replacing the 0 because this is what we always do. So then I have to call player turn 0 for this to replace it. I'm sorry, I'm just looking at a German keyboard. So okay, so this is still the index. What am I? Ah! Okay. Wow. We're going through everything here. Going through every field. And use this function to check the buttons. And then we go through this. And I have to replace the columns. And this is R1B. And it's probably R2B. This is, yeah, right, this is what I replaced. R2B for the next column, so it's R1B 3 times, R2B, and then R3B. 3 times. So this is our row of number. And then we can replace this with I as well. Okay, and okay, I'm going over this in a second. I'm just copying this here, and we have the states as well. Length of 9 for the array. Let's also make this U and 8T. And whoa! Wow. Huh. Yeah, this is annoying. Okay, so this looks a bit like wasted space, but this is just 1 byte, so I don't think that's really that bad. And now we only have to go through this for loop, and we check the button presses for, well, each button. So we have the row number, we have the state, and I just messed this up because I don't have the the column switching in there, so that doesn't make that much sense. We can just say this is this row, and then we say it is the row, and then I don't need the array up there. Ugh, okay. Okay. Wow. Ah, thanks. Okay, so we're flipping the thing. What am I doing? Okay. Yeah, this was all not that sensible. Okay, I thought I can just go through all the buttons in one go, but I think it makes sense if we have the row that's changing and the state that we are giving it. Let's say player turn, and this way we can get rid of most of the things here, but I also have to I could go back to the array and just replace it with one array and going through this, and then yeah, but that doesn't make that much sense. So we're all checking it again. R1B and 0 is the first one. That can go away now. Then it's R2B and state 3 because it's going down. Alright, and then R3B and state 6. Right, and then we have the row switch, sorry, the column switch. Okay, so R1B and 1, then 4 and 7, which is correct, and then we're putting this one here. It's R1B, state 2, 4 probably, and 8. 4 is wrong because we had the 4. Why am I? Oh yeah, I get distracted. So it's 2, 5, and 8. 2, 5, and 8. Okay. And then we're turning off that column as well. So so now it is a bit more sensible logically, and we don't have that much code anymore. These are the LEDs. We'll just let it draw how it's drawing it, because it doesn't really look very clean, and we could probably also go over this functionally, but yeah, I don't really want to do that. We're worried for the check if you want something. Right. Okay, so let's try to compile this. This is working. Let's upload it, and see the serial with the 8, 7, 6. Right. Okay. For some reason it did a reset. maybe. Okay, we got that one. Woohoo! It's working. Okay. So we have to check for when, and then we know the button is pressed. Okay, so we have that one. And the idea now is just really say, okay, we have, for number 1, we have like 2 or 3 numbers to check, and or I don't want to write the switch, so I'm just doing the if button pressed. Now we need to know whose turn it is, so I want to track that as well, the serial print. Hey. Okay. And bloop, 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 bloop. Turn off. Was it just turn? Yeah. Button. Okay, now, sorry. Now we have some debug. Right. I'm not sure how I'm resetting it, but sometimes it's probably the USB cable or the connector of it. But yeah, we that's so weird. Okay, yeah, that works, and we know whose turn it is, and we can verify that we have the turn variable here. That's pretty neat. Right. So now we can say if button pressed equals 1. This is annoying. I'm looking at the keyboard and it always tricks me. Now we need to know, yeah. Okay, if the first button is pressed, that's 0. Then we want to check if the other combinations are pressed, and I am quickly scrolling up to get the scroll past everything else that we were talking about. Winning combinations. Okay, so the good thing is, because I started with a 1, these are the first combos that I have to check against. We have to see if it's 2 and 3, position 2 and 3, which means 1 and 2. Okay, and we have the state array. This is somewhere here. Right, so we know the button pressed, and that's the same number of state. And this one has to... What am I doing? Okay, right. button pressed 0. That's our 1, and we want to compare that with. Right. This doesn't matter. Button pressed is 0 because we got here. So we want to see if the state of the 1, basically the second field right now is 0. But we don't care for that. We want to know if field 2, the top center one, is the same as the one we are playing right now. We don't have to check for if it's 1, then see if it's 1, because we can just do it like that. And this is state 2. This turn. Then we want to print something. Whoa. Okay, it compiled. This is nice. So let's see if this works and if I can push the buttons without it resetting. So we are starting with X, 0. Oh, sorry. Restart. Right. So we're starting with X. And now we're checking for this line. So basically, when I push this, it should say someone won. And it doesn't. So what did I do wrong? 1, 2, 3. 0, 1, 2. If it's button pressed 0, and this one is the same as this one, as turn, and state 2 is turn, it should print yay. Am I doing the AND wrong? This can happen because I'm used to something else, but no. If button pressed is 0, what's the serial saying? Turn of 2 is 2, turn of 2 is 1, turn of 2 is 0. Let's just enter another serial print, but it should have. Oh. Okay. Let's see if anyone in the chat got it before me. Probably. If I see something. No. Okay. So the code that I just wrote is definitely checking for the row, but it's only checking it if you press button 1. Exactly, Johnny got it. So this basically means I started with 0 and the check was run, but state 1 and state 2 were set to 0, so because there was nothing yet. So when I got to the third field and I was expecting for it to recognize the win, yeah, I was disappointed. And yeah, I should have done it backwards. So let's just test the theory again. Yeah. Well, we also want to see our success, of course. Yay. All right. Yeah, Johnny won. you've beat me in TicTacToe, tick trick and track. Tick. No, we're not singing now. Okay, so now I have to put that in for every number and every situation, which is kind of annoying. Because that means when we have 3 scenarios for the one to win, I have to write the 3 down there, and I also have, well, basically I now have to write 24 combinations, or like button presses and then something else, because I have to check if one of them has, like we just saw, if the 3 gets hit last, I don't have a check for 1 to 3 anymore. So so the brutal routine now would be to copy this and then really just say, okay, 1, we check for 5 and 9 and 4 and 7, or 4 and 8 and 7 and what? 4 and 8 and 3 and 6. Well, yeah, okay, you have a point for this variance, how we did the thing. So I could also just check for the state, because we don't, yeah, if any button is pressed, we just check if the 1, 2 and 3 state are turn. So then I don't have to write down 24 states for each button pressed, but I only have to check for the combination. Right? Yes. Right. Okay, so the if button is pressed doesn't give us any pointer, so I wouldn't have to do that. We only have to check for turn, unless we want to show how we won. Okay. So okay, so this is how we would do the 8 wins instead. I can also throw it into an OR, but this is easier to copy, I guess. Right, so this is just a placeholder with a print in the A. We can then say, okay, go to animation for winner number 2 or winner number 1, and then we can show the cross. But let's just quickly, okay, 1, 5, 9. That's 0, 4, 8, and then 0. I'm just taking them with me. 3, 6. 1, 4, 7. That's nice. Well, it's just shifted by 1, but this is an extra confusing part. 3, 5, 7. 3, 5, 7 is 2, 4, 6. 3, 6, 9. Four, 5, 6 is 3, 4, 5. And 7, 8, 9 is 6, 7, 8. Two, 4, 8. I just now I'm confused. 2, 4, oh, 2, 5, 8. Oh, what? Not 2, 4, 6. 2, 4. Yeah, it's a bit late. Let me just add this as a comment. Like, okay. Thank you. Let's see. 1, 2, 3. Did I run past this? No, that's looking correct to me. C 147, 147. Okay. D 147. Three, 5, 7. Ugh. 3, 6, 9. It's probably the last one, and Johnny already wrote that, right? H. B seems to be correct with 2, 4, 8. F 3, 6, 9. We got all that. Four, 5, 6. Johnny. I'm just looking for that replay on my computer. 6, 7, 8. No? Oh, Arduino, why are you doing this to me? So Johnny, are we alright with all the numbers? I guess so. Looked alright. We'll probably have to fix that typo somewhere in between there. Okay, let's upload. Yay. Clear output. Alrighty. Let's build a stair. We don't have a yay. So what happened there? Zero, 4, 8. I haven't seen a 0 for 8. It's there. So the turn stays, and we had that working with the, whoopsie. Zero, 4, 8. I'm a bit confused. We have the one with the 8, the one with the 4, the one with the 0, but we haven't pressed yet, right? That's why the button state was interesting. Okay, so we have the player, and we decided here that everything is alright, so we can set the state, but since we set the state of the last button after the check for win, because Johnny said so that we do this, yeah, I was pushing the buttons. I was pushing 8, 4, 0, but at the time I was pushing 0, only 8 and 4 were set to the state we're putting it to. So I was first checking for win and then setting the piece. So we, oh, why did it jump like that? Ah, okay. So we have the state and the turn, and we want to set it first, and then we want to check if we want something. Done uploading. Animation is done, so let's do the stair again because it was that much fun the first time. Sorry, killed the surprise. Yay! I won! Okay, that's pretty neat, but let's also... Why did I win again? 1, 6. 1, 6. Turn of 1. I won with the 6. 6, 7, 8. Two, 4, 6, 3, 5, 7. 2, 4, 6, 4. It's not bad. 0, 3, 6. 0, no, 3, 6. Every new click is a 1. Yes. Okay, Johnny, you're right. It's a bit late. I said that all the time today. But yes, of course. So, this is not dependent on the click anymore. So we're not checking if one of them is clicked. So when I just go through all of them all the time, whenever something is pressed, then of course, if it's my turn again and I press 0, if I press this, of course there is no yay you've won, but when I press here again, yeah, it also says yay again because it finds this one here. So just to add on that, onto that, oh, I just reset it. Right. If we do the circle double win, it should say yay twice at the end. Or it resets. I'm not sure, maybe I'm zapping it when I'm touching it. Double yay! Okay, yeah. Fine. This is sensible, but we also want to change the game state at this point and say somebody won. And then we can finish this up. Okay, I think I know what we are working with. So startup level is being used for the display sequence, it's empty, it's phasing, and then it starts. And it's in this loop here. So this is the first time it's called, and the second time maybe it's resetting because of that. I have no idea. That's something we could check. Okay, but like there's an overrun and it's playing with the start time. Maybe that's why it sometimes resets that weirdly, because it's doing this routine again, but it doesn't reset. So yeah, right. Let's put an if around the whole check button sequence. Caps lock. And say if this is 2, then we do this. Bye Johnny, thanks for all the help. I will probably not manage anything without you. Okay, everything after that is still just drawing the LEDs. Okay, I'm misusing the startup level now for the win scenario. Whoopsie. Okay. And 4. So startup level 3 would be when X wins, and for this I'm just saying can I do that here? I don't think I can. I probably have to write another array and copy this in, but let's just try this. Oh no, that's not working, right? So if I say zero, 1, 0, 1. Cannot reassign, right? Yeah, okay. I cannot reinitialize it, that's a thing. So let's just add 2 states and we'll copy that into the state thing that's been drawn the whole time. So that's basically our frame buffer for the LEDs. We say that this is a win for X and this is a win for O. And then it's, we're drawing an X on the LED matrix with the axis, and then we're drawing a circle thingy with the circles and say that's win 0. Okay. And okay, so this is right. It's a bit through the eye from behind, as we say. 8. Oh, I want to bring this to a state where I can say Y to everyone. I'm basically just writing something that goes through the loops and copies it from the win array into the state array so that it gets drawn. But if we're caught in that startup level, we are basically doing that all the time before drawing something. It's not really efficient. But yeah, win X I. Oopsie. Okay. Oh, okay. Now for the whole win thing, we just say it's here. Okay. Startup level is 2 plus turn. I did the caps lock thing again. Okay. So the idea is here that the win scenario is in the startup level. I should have renamed that. Startup level for me now is like a point of the state machine, which means 2 is where we play, 0 and 1 is for the start animation, and 3 is now for winning, for X winning, and 4 is 0 winning. And since we have turn, where 1 is X and 2 is 0 or O, this kind of makes sense to just add turn to 2, which is the last one, and then we have the right level for winning something. We just have to copy that in everywhere. We could also work with a boolean that gets set in here, and then we check the boolean afterwards. But we don't. This would be interesting if we want to count how many times we've won. But here we are just interested in getting to the hey, we won phase. Okay, it's in here everywhere. I did something stupid there because it's not 0, but oh, okay, it's compiling. So let's just try to win something. Also, right. Yeah, we could reset after that. I could also work with the timer now. But yeah, let's just go in a circle and maybe... Oh. Okay. How did I win? Okay. I think I had the diagonal line going there, but I was going for this one, so yay! I should probably work with a delay and then, or I can't work with a delay because then it wouldn't draw anything. But if I use the timer and then just tell it to wait a second and show the whatever is happening there. Like, I think it was already used here in the with the millisecond startup time. So I would have to set the timer when I come from the yeah we won thing. Okay. Right. So we're setting the timer, and then in here we can basically say just stay in that scenario for a second and then show that somebody won. I hope. Okay, so let's yay. Okay, so now I had the time to realize, oh good, I won, yay. And then it shows me the X in green. So yeah, it's probably correct anyway, but let's just try to win as orange. Nice. Okay. And now we could also play with the timer some more at another level and then say, now reset, please. By just throwing it from level 5 to level 0 again. But yeah, you kind of get how I did that, right? Let's just copy this again. Bloop, 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 bloop. And do this and say startup level is 5. we copy this, and then let's just say we enjoy our win for a bit longer, and if the time is right, then we say startup level 0 again. And then we can play endlessly. Right, so yay, X1, reset, animation. That animation was weird. That was even weirder. I think there's the flip is missing, or I'm not setting it correctly again. I think I have to yeah, it's not resetting the frame, it's just flipping the first start state. So I would also have to copy this one into the state first and then do the flippy bitty thingy. That's why it turned green and the other time it didn't. And yeah, so yeah, I think it just flips it. Anyways, yeah, let's maybe finish up here. Is anyone still watching? It says to me 12 people are watching. So I don't think I'm gonna do another stream doing the whole logic thing unless I really have a good idea, and maybe we can talk over it. So, but I was thinking about making a little case for it as well, because yeah, the 9-volt battery is a bit dangling around, so maybe that would be nice as well. I'm not sure how to mount it though, so I probably would have to design something that I'm not shifting, or just, yeah, that would basically, what's the word for it? I would make a little groove so the PCB can slide in inside, and then it gets held by that. But then you also have to make, yeah, at an end, like a cap, or I don't know, I'm not sure. But otherwise, yeah, this was kind of fun to think about how to solve the whole game. Yeah, I hope you enjoyed it a bit. Anyone else, any ideas? Is the chat still alive? Let's wait for some interaction from the chat, because it takes so long, the whole leg is so long. I probably have to ask somewhere online, like, hey, do you know what I could do? And then people would be like, yeah, did you try this? And I'm like, no, that's why I'm asking. I see myself still scrolling in the code. Did I just do that because I was not sure what else to do? Oh yeah, right now I'm talking about changing the state. Wow, this is laggy. I could just write in the chat. Yeah. Ooh, 2 minutes. Wow. Okay, so I basically just stood here for 2 minutes and didn't say anything. Oh, I'm sorry. Okay, James liked it. Have a good evening too, James and Rory and everyone else watching. I see 11 people watching. Yeah, I'm just gonna shut this down now. I'm not sure if it ends then, but yeah. Thanks everyone for watching. I hope you're interested in getting this thing and maybe not trying to program this. I will share the code soon-ish. I might do that tomorrow because it's a bit late. But yeah, thanks everyone, and yeah. See you when I see you, or you see me when you see me. Yes, I don't see you. Alright, have a nice Friday evening, or whatever time you're rocking this right now. Sion's weekend already started, if you're still here. Yeah, have a nice one. See you next time. I'm in a loop. Help. Help me.